not stop now. This is the title that we decided to give to this webinar series, whose function is that to keep on discussing and having, sharing research work, even in this difficult time due to the COVID pandemic. Today, we are really honored and delighted to have here as a speaker, Professor Mercedes Delgado, that we thank a lot for having accepted our invitation. Mercedes is currently Professor of Strategy and Innovation at the Copenhagen Business School, and she's also research scientist at the MIT Innovation Initiatives, and she also serves at the Harvard Business School as Senior Institute Associate, okay, and the Institute of Strategy and Competitiveness. I'm very happy to have her here because I think that her topic fits perfectly our social sciences group. We all know that Mercedes Delgado focused on the relationship between the regional business environment and the performance of inventors, firms, regions, and countries. So her topic are perfectly fitting with the series and with the social sciences group at the Renaissance Science Institute. And I mean, the contribution of Mercedes are simply outstanding. I don't think that she needs really presentation from myself. We currently work daily on what she has proposed as new methods for defining and mapping industry clusters. I think that we have at least quoted here one time everyone here. So I think she's pretty well known, and it's really an honor having her here today. Recently, I think she's going to tell this pretty soon. Mercedes has won a National Science Foundation grant on mapping the inventor gender gap, and this is pretty related to a presentation. And I now leave the virtual floor to you, Mercedes. Welcome, and please, the word is yours.
Sandro, thank you so much for such a kind introduction.
I forgot to tell the rules of the game. Sorry. So the rules of the games. Sorry, Mercedes, I interrupt you. The rules of the games are usually the following. So we're going to have 1 hour time maximum for Mercedes' presentation. Although I've been told by Mercedes that during this hour she will move between different topics. Right? So there will be sort of change of topics along the route. And during this change of topics, we might pose to air, brief spotlight question. And as usual, just write the question on the Q&A bottom, and I will report this question to Mercedes. And as usual, at the end of the hour time for our presentation, we can have a more extended discussion, collecting questions and rebooting the questions we get. So this are the rules of the game. I don't know whether, Mercedes, you want to add more in terms of preferences from your side.
That sounds great. And so from time to time, I will stop to check if there are some questions. But I think it's also great to have at the end these 20 to 30 minutes for questions and answers from the audience. Yeah. So thank you all. And thank you, the Grand Sasso Science Institute, for the invitation to present today. The work that I'm going to present is called the Inventor Gender Gap, Catalyzing Change. And this is joint work with Fiona at MIT. And as Sandro was mentioning, this work has been supported by a big grant from the National Science Foundation. All right, let me see if perfect. So here is myself. I'm a professor at the Copenhagen Business School. My co-author, Fiona, she's also a professor at MIT Sloan and the Associate Dean for Innovation and Inclusion at MIT Sloan. We've been working with a big team. This is a big project. And I would like to take the opportunity to thank all the collaborators, and in particular, the great research assistance work done by Luca Hughes. He's an MIT Sloan PhD student, and also Peter Favaloro, Rich Bryden, and others. The outline for today is that I'm going to first give you a big overview of the project, but then I'm going to focus on one particular paper, the role of universities on catalyzing gender inclusion in innovation. So the motivation is easy. Unfortunately, is the missing female inventors in the US and in the world. An inventor in our work means that you're an individual with a utility patent granted within an organization. As part of this project, we developed a name gender matching algorithm and computed, based on that gender name algorithm, multiple female inventor inclusivity scores. And what we find is that only 10% of inventors are women in 2015 in the US, only 10%. And only 14% of all the new inventors are women. And by new inventors, we mean that this is your first patent ever granted to you. Now, the gap is also persistent. So since the 2000, the rate of improvement has been very slow. Actually, we estimate, based on the slope in the last 16 years, that it will take 250 years to reach parity in the percentage of female inventors in the US economy. Now, we cannot wait so long. As I mentioned earlier, this is a global problem. There is a similar gap in other countries that has been documented in prior work. We very recently, like a month ago, we finished computing some of these scores for Denmark, and we also find very low numbers. 13% of all the inventors in Denmark are women. So really, this is like a global problem. And as part of this project, what we ask, what can patent data at the organizational and team level tell us about how to accelerate change in inclusion? Who are the people and the organizations that can be catalysts? And by catalysts, we mean accelerating the change, engaging more young women in patenting. Now, the low presence here, again, motivating the problem. Female scientists and engineers have long played a critical role in the global economy. Here are some well-known examples from different countries. And yet, their low levels of inclusion in innovation, it really is a huge pressing issue problem. This lack of low levels of inclusion in innovation is particularly striking in patenting, based on the scores that I just mentioned to you. And the problem is so large that inclusion in the innovation economy has become not only an economic goal, but also a social goal. Is one of the UN Sustainable Development Goals. SDG number 5 is to improve gender equality. Now, why all these missing inventors? There are multiple barriers that can be limiting the ability of women to engage in innovation, and in particular in patenting. A lot of the emphasis, and many have argued that the problem is the lack of entry into STEM education, so a problem of supply. However, we have seen, and I'm going to show you some numbers throughout the presentation, that the number of women engaging in STEM education, and in particular STEM PhDs, has been improving rapidly, but we don't see such an improvement in the engagement of women in patenting. So this suggests that there is an inefficient use of the female STEM talent. And now, why is that? There are a few insights from prior work that there could be organizational and also team level factors that could be impeding women to engage in patenting. Author Fiona shows that actually women do want to patent, and when you reduce some of the barriers, like for example, better access to the CTO office, better access to industry boards and industry collaboration, you can see how female faculty actually are going to start and increase their patenting. Another potential driver is the lack of access to knowledge networks that you need to become an inventor. And in other part of the work, we actually find that female top inventors are more likely to collocate geographically with the inventors in the team. So they need to be close to the knowledge. That means that as some of the patents and knowledge is becoming more multi-location, that could be an additional barrier for women to engage in patenting. And that's part of a separate paper that is not going to be the focus of today. Let me step back about this project, and it has it's a two-stage approach in this project. A big part of the project, like over 2 years, we've been working on mapping the female inventors and building new indicators and indices to measure female inventor inclusivity. Then, on the second stage, we are going to use the variation in those inclusivity scores across different settings to understand catalysts for change in inclusion and innovation, and in particular, looking at the role of universities, firms, and particular locations and industry clusters on the inventor gender gap. So let me discuss the step number 1. What we do is that we are going to build these inclusivity scores and indices across locations. So basically, we're going to map all the inventors by gender in the US, and then we are going to compute different inclusivity scores across cities, economic and technology fields, across different types of organizations, for example, firms versus university. We're also going to give scores to particular people, like the top inventors, and also we're going to examine these scores over time. Now, what are the scores that we're developing? One of them that I already introduced to you was the percentage of female inventors, and we saw it's only 10% in the US in 2015. A very important one that we also developed is this percentage of female new inventors, your first patent. And that number is 14% in the US. This is a very important indicator because the sooner a woman, a man engage in patenting, that can have long-lasting effects potentially in their career. This indicator that we have introduced have now been used by the USPTO, recognizing the importance of tracking these female new inventors. The third score, the percentage of female patents. Now there, what you do is you're going to take into account that an inventor can have multiple patents, and also that one particular patent will have multiple inventors. So you're going to distribute each patent across gender. And that indicator is lower, is 8%, the percentage of female patents. And then the last one, which we don't pay a lot of attention, is the one that we often hear about, the percentage of patents with at least one female inventor. That number, of course, is bigger, right? It's 19%, but the problem is that in many of the studies, this is the indicator that we're focusing on, and that indicator is over-optimistic because it's ignoring that in a patent, very often the average team size is going to be around 4 inventors. So having one female inventor is not a good indicator of whether or not there is inclusion in engagement in patenting of women relative to men. Now, it's also important to look at indices. And why indices? Because the patent composition across technology fields is going to be different across organizations and also for universities versus the US economy. For example, at the universities, a lot of the patenting is going to be in drugs and medical. However, in the US economy, a large percentage of the patenting is going to be actually in IT and communication equipment. And these two fields have very different supply of women with STEM skills. So that's why we also develop new indices that are going to be a weighted average of the technology class sub-scores relative to the US, so that we can really compare organizations that have different technology field specialization. And I'm going to be more concrete with some examples. So here you see an example of how we are mapping these female inventors. Now, this is across economic areas in the US. The score is the percentage of female new inventors. All the economic areas in pink, they have a score above the US average, which is already low, it's 14%. And the ones in blue have inclusivity below the US. The size of the bubble represents how much patenting is happening in that particular economic area. Not surprisingly, there is a lot of patents concentrated, for example, in Silicon Valley, in California, but also in the East Coast, Boston, New York, and so on. And what you can see here is that there is a very large variation both across states, but also within states. For example, in Texas, you're going to have some regions that are more inclusive, like Austin, versus other regions that have lower presence of female new inventors. Also, for example, when you compare Seattle, a very low presence there of female new inventors versus, for example, in Boston, that's doing much better. And the idea is that then use this data to try to explain why this variation. Is it due to technology field? Is this variation across cities related to the inclusivity of the universities or the inclusivity of some particularly big firm that's patenting a lot? For example, in Seattle, we have Amazon is a part of the story there. So the idea is to then use this kind of very rich data to come up with new research questions and proper benchmark to understand these variations. Now, we also, as part of the project, we are going to examine the inventor inclusivity of firms. This is preliminary. Here you have the percentage of female inventors for the top 30 patenting firms in the US. Why these firms? Well, these firms, potentially they can be catalysts. Why? Many of you may know that in the US there are more than 5 million firms. 5 million, many. 30 firms, the ones in this graph, account for 25% of all the patents in the US. So the patenting activity is very skewed in a few big firms, which means that potentially the inclusivity of these firms can have a big impact in the economy. And here you see the ranking, just to illustrate how we can use some of these scores. You can see big variation again from Johnson & Johnson, a score of almost 18% for the percentage of female inventors. IBM, not surprisingly, perhaps given their emphasis in patenting, also doing well, ranking number 5. Compare that to, for example, Apple, that's ranking 27 in this analysis. And of course, this is just the beginning of the analysis. The idea then is to try to understand why this variation across these organizations. Also, what is happening within these organizations? They have many business units, and there is going to be variation across business units in how well they engage women in innovation. And we are actually working with some of these big firms to try to actually understand why the low numbers. Is it a supply problem? They're not hiring enough women in STEM, or is it that they are failing to engage them at the same rate that they engage their male counterparts? Here now, I want to illustrate this score versus the index, because it's also going to be relevant for the particular paper that I'm going to discuss. Here we have the female percentage of female new inventors across the top 25 universities in terms of patenting. First, in the first column, we have the score. You can actually see that all the universities seem to have higher scores than the average in the US. If you remember, the average in the US was 13% during this time period, exactly, for the percentage of female new inventors. And you can see all these universities are doing better. And there is, once again, there is variation. But then the score is not enough. It's informative. For example, at MIT, 19%, the percentage of female new inventors is 19%. However, this score doesn't take into account that MIT may have a different patent composition across technology fields than other universities, like, for example, the University of, I don't know, the Southern California, all right? In particular, at MIT, you have a lot of patenting in mechanical engineering, which is a field where you have fewer women. So that's why when you compute the index, that is going to be a weighted average across technological subfields, MIT does better than when you look at the score. And actually, let me explain what a 5% means for the inclusivity index. It means that compared to the US, once you control for the different technological composition of patents at MIT versus the US, MIT have 5 percentage point higher score for the presence of female new inventors. And once again, in this graph, you can also see that all the universities except one, Case Western Reserve University, are doing better than the US economy in terms of engaging new female inventors. So that gives you an idea of the different scores and how we can map them at different levels of analysis. Then in the stage number 2, which is the focus of today, we're going to use the variation in this inclusivity scores across different types of organizations and different people to try to understand who are the catalysts for change in improving inclusion in the innovation economy. And in particular, we look at the role of universities. That's the focus of today. We also have some work looking at the role of firms and the spatial distribution of these firms, and as well as what's the role of location. But it's not the focus of today, but I'll be happy in the future to talk about these topics as well. And now, why the focus on universities today? Because at the university level, this is a particular setting where we actually know the pool of potential female inventors to be, meaning that we know the supply of women with STEM PhDs, and that's the pool of people that are at risk of becoming an inventor. And they can be not only the PhD student, they can also be with the postdocs and the young female faculty. That's the supply of women with STEM skill that could engage in patenting. That is very hard to know in firms. And actually we're discussing, we're working with some big firms that do a lot of patenting. And when you ask them about what is the STEM skills by gender in your organization, they don't know how to answer. They haven't been collecting the right data. So, and as a result, they don't know whether they have a supply problem. They're not hiring enough women with the STEM skills, or, and probably an inclusion problem. We're not being efficient in the use of our female human capital. So that's why we start with universities. We're going to control the supply. But also, it's very important to start with university because they train the majority of the STEM women and men. And they're the ones that can intervene early in training inventors to be. So that's going to take me to the focus of today's talk, which is the role of universities and their top inventors in catalyzing change. And maybe this is a good time to pause even for 30 seconds to see if there is any questions so far.
Yeah, I don't see questions from the chat and from the Q&A bottom. So any question? We have also people following us on the YouTube channel. I forgot to mention this. And we have Andrea Scani following attendees on the YouTube. Any questions from the YouTube, Andrea? I assume not, otherwise you would have told me.
Yeah, no questions from YouTube.
Perfect. Okay. Very good.
So you have been pretty crystal clear, Mercedes. So everything's pretty fine and understandable up to now.
Excellent. So now we're going to move to this paper, and the empirical questions that we're going to try to answer is the first order question: are universities catalysts for gender inclusion and innovation? And to answer that, we're going to break that question into four. Are patents by universities more inclusive than the US economy? And you already saw from the analysis before that it does seem that that's the case. Is university inclusivity aligned with the supply of female with STEM PhDs? So supply versus the conversion of students into inventors. The third question is that among the academic inventors, who are the catalysts? And we're going to be looking at the top inventors. And the final question is, do academic top inventors differ by gender in how inclusive they are themselves? As I mentioned earlier, universities, why are they so important when we think about inclusion? Because although they generate only 4% of the patents in the US economy, they are training all the STEM people. And they also, as I'm going to show you later, they're generating many new inventors. They can play a role in shaping, imprinting early on the skills and innovation expectations of young STEM talent, in particular PhD students, master students, postdocs. And this role, we know, is important because the attitude toward innovation actually shaped very early on during your graduate studies and experiences. And we know this from prior work, including some of the papers cited here. Now, if universities engage more new female inventors, these women now have the skills for becoming more productive, perhaps during their future career. Now they're going to be officially, they're now an inventor, they have more visibility, they know how to invent, so potentially that can help them during their scientist career, inventor careers. It's also very important because people think that PhDs in STEM, they just want to stay in university, and that's not the case. The large majority of STEM PhD graduates are going to be working in firms. So there can be large externalities from the training and engagement in patenting that they get during their PhD studies. They can take that skills with them when they move to work in firms. And as I mentioned, the majority of them, 60% of them, will be working in firms. And remember that those firms are the ones that are producing 96% of the patents in the economy. Now, for the analysis, the baseline sample is going to be the top 25 universities by patenting in the US. We focus on these top 25 because, once again, we're looking for organizations that can have a big impact and can be a catalyst. These 25 universities, they represent 12% of all the universities in the US that patent. This sample of 25 universities account for more than 50% of all the university patents in the US. In particular, in our sample, we're going to be looking at around 32,000 patents by 37,000 inventor university pairs during our time period, 2000 to 2015. And these universities also are going to count for more than half of all the new inventors that all the universities in the US generate. Now, do they do better in terms of our female inventor inclusivity scores? They do. Universities have much higher scores, both in terms of levels, but also in terms of the growth trends. Let's look at some numbers here in this table. For example, if you look at the percentage of female new inventors, it was 22% in 2015 in the universities versus 14% in the US. So a significant percentage gap. At the same time, when you look at the trend, so the improvement in this score in the last 16 years, the improvement is faster in the 25 university, a 4 percentage point change, versus in the US, 3 percentage point. The same findings hold in the paper that we will be releasing the paper very soon, but the same findings hold by technology field, and also if we use our inclusivity indices that I just explained before. But even if universities are doing better than the US economy, still they will only reach parity in the percentage of female inventors in 169 years. That means, and if we then look at the percentage of female new inventors, parity will happen in 103 years. So that's many years. So that motivates the next question. What's the problem? Is perhaps the problem the constraint in terms of the supply of women that enroll in STEM PhDs programs? And that's an important question. And actually, we spend a lot of time in this project trying to actually understand, do PhD students engage in patenting? And we have a very important finding. The finding is that PhD students are a very important source of new inventors in universities. And initially, when we mentioned this to big scholars in the field of innovation, they were surprised. They thought students are too young. How are they going to be engaging in patenting during their PhD studies? But the reality, this is something that we knew very well from just the MIT case, But it turns out that we have done a lot of analysis to try to measure that. What is the percentage of the new inventors in these university patents that are PhD students? Because we're trying to understand what is the relevant supply of the population at risk of becoming an inventor. Now, during our time period, here is a very good piece of news. These top universities generated more than 20,000 new inventors, their first ever utility patent granted. Many of these new inventors are PhD students, and we implemented analysis at 3 levels. The first one is that we look at detailed data from MIT. We look at all the new inventors, almost 1,800 of them, in their 2000 to 2015 patents, and using a very unique data set of all the roster of all the MIT students and faculty and inventors, we were able to compute the exact number. So the percentage of the new inventors at MIT that are PhD students, meaning that they filed the first patent when they were engaged as a PhD student at MIT, is 41%. Now, let me also explain here, this was a very required collaboration with MIT TLO, MIT Institutional Research, so we're extremely gratefully required also signing NDAs. It's been a very data-intensive process, but a very important one, trying to understand who are these new inventors. Now, to continue to make this point, who are these new inventors, something that we don't know much in the literature, that has been focusing on faculty patenting, but not students patenting. We then did another exercise that was also very time intensive. We created a random sample. This was a representative random sample of around 1,000 new inventors, 42 new inventors for each of our 25 universities. And we did, with the help of fantastic research assistants, detailed online search to figure out who were PhD students when they filed their first patent. And the number is similar, 40%. And now the most recent analysis, because the thing is that this finding was so important that reviewers keep asking us to know more. So now we have the MIT sample, then we have the random sample. At the end, we realized that we needed to look at all the new inventors in the 25 universities. And to do that, and with the fantastic help of Luca Hughes, our PhD student at MIT Sloan, that is currently very active as a research assistant in this project, we have now searched for all the new inventors in these university patents using the ProQuest dataset. And we found, and we're still improving the match, but we found so far that 30% of all the new inventors were PhD students. And this is major. Now, this really indicates that universities can have a very long-lasting effect because they're creating all these new inventors during PhD studies. But then the question is, are these opportunities available equally to the female versus the male PhDs? Now, I'll have to accelerate a little because there is a lot of new analysis at the end, but basically here what you can see is that the good news is that the percentage of female with STEM PhDs has been rising, has been improving fast during our time period, the 16 years. For example, from 24% to 34%. And that's good news. The supply of potential female inventors have been increasing fast. However, when you look at the percentage of female new inventors, which is the dashed line, it hasn't improved as fast, right? And by when you look at 2015, you can see a large gap between the percentage of female PhD students and the percentage of female new inventors, which means that we are missing a lot of potential female new inventors, and that women PhDs engage in patenting at a much lower rate than the male PhDs. So there is room for improvement here. We then look at that this is also the case by technology field. Here you have drugs and medical patents. They have the highest inventor inclusivity score of, if you look at the table, 29%. However, that number, although looks significantly better than the US average of 14%, that number is still extremely low relative to the supply when you look at the percentage of female with PhDs in biological and biomedical sciences. That number is almost 54%. So that is a 24% gap, right? Which once again tells us that we're not using efficiently the supply of women with STEM skills. And this also suggests that the problem with the inventor gender gap is not just about STEM education choices, which has been the emphasis in a lot of prior work and also in the policy narrative. Now, we then try to think, okay, so if there is this opportunity, let's then think about who within the university can be people that are catalysts. And we look at the top inventors. Why we look at first, how do we define top inventors? These are academic inventors that have more than 7 patents during our time period, and 7 patents is just the 90 percentile value of patenting proficiency in the US for an inventor. So that's why we need a number that is high. But of course, we do sensitivity analysis around that. Based on that definition, there are around 2,200 top inventors in the 25 universities. They represent 6% of the inventors in these universities. However, they're going to be listed in 60% of the university patents. So really, these few inventors account for a lot of the university patents, so they can play a big role in university innovation, inclusion in innovation, their autonomy, their reputation, their patent intensity gives them a key role in shaping the organizational culture of universities as it relates to engaging women in patenting. Furthermore, most of them are going to be faculty, many of them are going to be also running labs, so they have this important role in training PhD students and translating them into inventorship. So what we then did in the paper is that then we, to try to understand the role of these top inventors, we compare patents that have a top inventor versus patents without a top inventor. And we're going to look at, for each patent, the percentage of female new inventors among the team in the patent. And so basically, the dependent variable is the percentage of female new inventors. The explanatory variable is the type of patent with a top inventor or without. And then all sort of controls, the size of the team in the patent, university fixed effects, technology field fixed effects. And the results are illustrated here in this figure, basically patterns that have a top inventor, so it's the bar in green, have almost 2 percentage point higher percentage of female new inventors as compared to patterns without a top inventor, which is the bar in gray. We then divide the patterns with top inventors in those that have a male top inventor in blue, a female and male top inventor in purple, and only female top inventors in pink. And you can see each of them is doing better than patterns without a top inventor, but you can already also see that the patterns that have a female top inventor are particularly inclusive. This takes us to the next analysis, where we're going to look at not at patterns, but we're going to look at the inclusivity of each top inventor. So the unit of observation is going to be a top inventor. This is going to allow us to look at the full portfolio of patterns of each of these academic top inventors, compare the female top inventors to the male top inventors, and also control for attributes of the top inventors, including their technology field, and also very important, which is the new analysis that we have done, controlling for the pool of their own PhD students. So here is an example. Here is Karen Gleason at MIT, professor of chemical engineering. She has a lab. During this time period, she has 19 MIT patents. She's engaging many of her PhD students in these patents, 12 of them. And you can see here our dependent variable. For example, the percentage of female new inventors for Professor Karen Gleason is going to be 41%. You can already see those numbers are very high. And when we compute the index, also very high, 29% better than the US economy. Similarly, we do the same for all the male top inventors. Here is a male top inventor, Professor Michael Sima at MIT. He's professor of engineering and material sciences. He's also the co-director of the MIT Innovation Initiative, also has a lab. During this time period, 38 MIT patents. And you can see a percentage of female new inventor, 15%, also very high, index 24%. So that's going to be our dependent variable. And the key explanatory variable is going to be the gender of the top inventor. Now, first I'm going to show you the simplest results using simple means. And what you can see already here, so we have the percentage of female inventors, the mean, across top inventors that are female versus top inventors that are male. And you can already see there a gap of 6 percentage points higher for the female top inventors. Similarly, when you look at the percentage of female new inventors in their own patents, there is also an important gap, in this case, 8 percentage points higher for the female top inventors. We then try to understand a little bit better, okay, why? One explanation could be just the field of research. Maybe these female top inventors are concentrated in fields that have more women scientists, like, for example, drugs and medical. It could be another factor, homophily. We know that cultural similarity play a role in the formation of inventor teams, and it's going to be homophily is going to be especially important for underrepresented groups, and women inventors is an underrepresented group. Another factor perhaps driving the higher inclusivity of the female top inventors could be mentorship of young female scientists, including PhDs, postdocs, faculty, and so on. And there is some evidence of that in the context of publications in prior work. But the prior work has also mixed findings. So to test this, we ran, now we're going to run, at least we're going to, of course, try to make sure that it's not driven by the field of research. So here is the very basic econometric model that we are going to run. The dependent variable is the inclusivity score, or the index, for the female versus the male top inventor, and we're going to control for technology class of the top inventor, their university, and other attributes. And you can see already that the gender of the top inventor explains significantly this gap in inclusivity. And here is the table, but I think it's always better to see it in a figure. And you can see here the female top inventors, which is the pink bar, have higher inclusivity, especially for new co-inventors, for the percentage of female new inventors. You can see that the gap relative to the male top inventor is 6 percentage point and a half. Okay, and so a big gap. Also, what you see in this figure is that we get the same findings when we look at the index. So this result is not driven by technology field. And to make that point even more clearly, here you have the same analysis, but now within a field. And still you can see that even within fields with many women with STEM skills, like chemical and drugs and medical, you still see a significant gap in the score of the female top inventors versus the male top inventors. So it's not about technology field. Now, in the next 15 minutes, so I'm going to use a little bit more time, I'm going to explain some new analysis that we have done throughout the summer and early fall to try to understand better this gap between the inclusivity score of the female versus the male top inventors. I'll pause for 30 seconds in case this is a good time to address some questions that may have.
I've seen there's a question on the Q&A button, though maybe referring to something you're gonna talk later on. I don't know whether it's the case to address it now. It's about question about the role of university.
Oh.
Have you seen it? To accelerate change in gender racial equality regarding the inclusion of Black and other ethnic female investors. So here,
it's a great question. Let's make sure we talk about that at the end.
Okay.
It's a very, what are going to be some of the challenges in doing that?
Yeah, we'll post it there for a while, okay?
Perfect. So now, why do female top inventors have more higher inclusivity? And we're going to try to look at a particular mechanism. We're going to look at the mentorship of their own PhD students. So in this analysis, and now the new inventors are going to be PhD students. They file their first patent with their advisor in patents that have been granted during our time period of analysis, 2000 to 2015. And there are two potential mechanisms that could increase the percentage of female new inventors who are PhD students. One mechanism is supply of female PhDs. Perhaps the female top inventors are mentoring more female PhDs, so they have a higher supply of potential inventors to be. And the second mechanism is the rate at which they're going to translate female PhDs into inventorship. So those are the two mechanisms that we're going to try to separate. This is very preliminary analysis, but very exciting. So let me show you what we find. So the first thing that we have to do is estimate for each top inventor their PhD students by gender. So we want to estimate the population at risk of becoming an inventor. How are we going to do that? It's been a very data-intensive piece of work. We are using ProQuest data, and we're going to match each top inventor to all their PhD graduates during 1995 to 2015. And then we're also going to use our name gender algorithm to figure out the gender of the PhD graduates. A subset of 40% of all our top inventors have PhD graduates, and also they have at least one new inventor among their own PhD students. And that's the sample I'm going to be using for this analysis. What do we find? We find, and this is just simple means, so it's just a preliminary, we find that the percentage of female PhDs is higher for the female top inventors. So they are mentoring more female PhDs, probably in their labs. And the gap is a big gap, 11 percentage points. This is consistent with some prior work that finds that elite male top inventors have fewer women in their labs, in particular, they're looking at life science and the presence of female postdocs. And that's consistent with that. It seems like these female top inventors have more female PhD students that are working and mentoring. And that can, of course, help explain the higher percentage of female new inventors. The second part, so that's the supply that we estimated, is that now we are going to compute the inclusivity score, percentage of female new inventors, but only among their own PhD students. And now the definition of a new inventor is going to be a PhD student of your own who filed their first patent with their advisor, who is a top inventor. To do this analysis, we observe when the PhD student graduates, when they publish the thesis, but we don't observe when they started. So we assume in this analysis that the duration of a PhD is 6 years. That assumption is based on very detailed analysis that we do with the MIT roster of all the PhD students and those that at MIT, and we can see that on average the duration in these STEM fields is 6 years. But of course, ideally, we would like to know when each graduate student started their thesis, their PhD program. So what do we find? Once again, this is based on very careful matching with ProQuest data. We find that the percentage of female new inventors among your own PhD is again higher for the female top inventors than the male top inventors. And the gap is 11 percentage points. This is a big gap. Now, what is driving this gap? Well, as you can see, part of the explanation of why these female top inventors are engaging more new female inventors is that they have a higher supply of female PhDs. And that was, if you remember, 35% is here in the table versus 25% for the male top inventors. So that's part of the explanation by mentoring more female PhDs and also able to engage more female students into patenting. However, when you look at the conversion rate from a student into inventorship, is very similar for the male top inventors and the female top inventors. In particular, the probability for a female PhD student to become an inventor, a new inventor, is around 20% for either the male or the female top inventor. So a 20% probability. That probability is higher for the male PhD students. It's around 28%. So still there is, although the female and the male top inventors do better than other academic inventors in university, still there is room for improvement, because the rate at which these female PhD students are engaging in their first patent is around 77% that of their male counterparts, which means that we are missing female new inventors. We are leaving behind some female PhD students that should be engaging in patenting during their PhD studies. So then I'm going to take sort of 2 or 3 minutes to conclude and then try to think about perhaps some policy implications of the work so far. And so how can we accelerate gender inclusion in innovation? I think, we think, based on our work, that we need to support universities. Universities, we have shown, play an important role in creating new inventors and engaging female new inventors. They're also more inclusive than the US economy. In order to engage more women in patenting, we think that it's important transparency. And by transparency, we mean that we need scores so that we can really assess a variation across organizations, across people, across locations, so that we can better understand why there are differences, but also we can then celebrate the particular organizations and people that are being more inclusive in engaging women in patenting. We also need to increase the number of female top inventors. We have seen in the data, they only represent 10% of all the top inventors. So it's a very small group. However, they are key catalysts. We saw that the percentage of female new inventors is much higher than that of their male counterparts, because they're mentoring. They seem to be mentoring more female PhD students, and in doing so, engaging them in patenting. So we need to increase that number of female top inventors. Now, how do we do that? There is some prior work here. Again, as an example, is the work of my co-author, Fiona. One way to increase the female top inventors is to give them access to the key resources for the commercialization of invention, like grants, like access to corporate boards, and so on. We also need to increase the number of female PhDs that are working with male top inventors. We saw that that percentage was much lower for the male top inventors. It was around 25%, when in the overall pool of the 25 universities is 31%. So these male top inventors should be engaging with more female PhDs in their labs. We also need more resources for the underutilized pool of female PhDs. We saw that the supply of women with STEM PhDs, that ratio is much higher than their present in patenting. So there is all this extra pool of underutilized female human capital that we should transform into inventorship, and that may require additional resources, additional mentors, additional grants. We also think that we need to try to understand those that are doing better, like Karen Gleason, like Michael Sima. What are the best practices, right? And can we identify best practices that can inform the inclusivity culture within universities and other organizations? Now, within doing all this, creating more female new inventors in university can have potentially a big multiplier effect in the whole economy, because these female inventors are then going to work in firms, and their training that in patenting that they receive while at the university can affect their future or may affect their future scientist career within firms. It's also that another channel for a multiplier effect is that if I, as a student, work with a top inventor that is very inclusive, that can have an imprinting effect on me, and in the future, when I myself create teams of inventors to produce new patents, I may also be myself more inclusive. So there are many channels that we could think and test where the inclusivity practices in university can have a multiplying effect in the economy. And I think with that, I will just leave it open for questions from the audience, including the question that we have in the chat.
Right. Okay, Mercedes, thank you very much for your fascinating talk. Now, as Mercedes says, I will open the floor to questions. There's already a question written there that Mercedes has already seen.
Yeah.
I don't know whether we...
Let me start with that one, yes.
Shall we start with that one?
Yeah, of course.
Okay, shall we proceed with that one? Okay.
Perfect. Casomes, thank you. That's a very important question. And indeed, in the context also of MIT, is something that we're trying to measure, not only inclusion of female, which is a clear minority, but also of Black inventors. And then definitely we see a lot of interest in trying to do that, recognizing that there is a big problem, but we need scores to understand how big the problem is. And what I can tell you, perhaps reflect on what are going to be some of the challenges of implementing this type of analysis. And this is also based on some discussion with the team at the USPTO. You need to figure out the race of the inventor. That's hard to do. It's hard to do based on the name. Sometimes there are some names that can help you associate those names with not only gender, but also with race. But it's much more complicated than that. So we all are trying to think, what are other techniques and methods we can use to predict the race of the inventor, so that we can better map what is the race gap in inventorship. Maybe another way to do is actually ask the inventors themselves to tell us their race. So imagine if the USPTO set up some initiative or function where the inventors themselves can self-report the race. That could be another way where we can try to gather the necessary data. At the MIT now, with the roster, we're now actually gathering data on race, and we're going to be looking at that in detail in the particular context of MIT. But it is challenging in terms of, it's extremely important to do that. Some of the factors that may be affecting the female gender gap, the female gap in innovation, may also be affecting the race gap in innovation. We don't know. We need to examine, but extremely important. Universities care, firms care. We're talking to big firms that are going to self-report, give us the information about race, but it's challenging. So we need to think about, as scientists, what will be a good method? What will be a set of methods that could allow us to come up with the right indicators so that we can better investigate this issue and catalyze change. So thank you for that question. It's an important one.
Right. So thank you. Then we have Alessandra Fajan who wanna raise a question to you. Alessandra, please.
Yes. Mercedes, very nice presentation, very nice topic, of course, when it comes to gender issues. Of course, I'm always very interested. Okay, so since you have your presentation still on, can I ask you, since I'm a regional economist, to go back to your map of the US?
Of course. And, you know, it's, I have a separate project on that, and I know you're very excited with that project. So
Yeah. And also because I lived in the US. Right. Okay. So this is really nice. And I had few thoughts about that. The first is, it's clear that there is a coastal areas versus center effect. So if I actually look at this map, I'm wondering, okay, with few exceptions like North Carolina and whatever, but have you ever considered maybe studying a little bit the link between the conservative view of a place and how many female actually do become inventors? Because I think it's a cultural thing. When you were saying that the percentage of PhD graduates in STEM is going up, if you think about economics, we have a lot of female students in economics now, and yet they don't manage to go above the glass ceiling. There's always a delay. First you provide, the market with a lot of female, but then there is always this cultural thing that needs so much longer to actually change. And in this case, I was thinking of two things. One, the voting party, whether they are more conservative or less conservative. And the second, it's also, this goes back to the question you just answered, because she was asking you about race, and I thought about migrants. So if you think about the coasts, where you have more migrants, so the East Coast is more from Europe, the West Coast, you have a lot of Asian migrants. Anyway, so because of course I do regional, I was wondering if you are planning to look maybe into this effect. And the second question I have, which is a different one, maybe I already told you at GeoInno when we were discussing about your upcoming projects. Do you actually think that the picture that you are showing us with patents may be worse than the real one, even though not that much worse, but maybe a little bit, because maybe female prefer other types of inventions, such as trademarks? Here I see there is Adriana Pinate connected, and we are working on different types of innovation, kind of more soft. Maybe they do more.
Professor,
more,
let me, Alexandra, let me, those two big questions. First, that's exactly what we want with this map, to motivate research questions and then use the data to think of many questions. One of them, another reason why the cost looks so good is that that's where universities concentrate as well. So a story could be a story of universities. They're more inclusive, and that is going to be affecting potentially, and it's something that can be examined and tested, the inclusivity of the regions. So, but a lot of the universities are on the coast. The culture, indeed, there is fantastic work by regional economists thinking about variation across cities in terms of culture, in terms of inclusivity culture in particular, including the work of Florida and others. And even looking at this map, perhaps it's not surprising that, Salt Lake City is a very innovative economic area. Salt Lake City, in terms of biopharma, medical. However, you can see it's very blue. And you wonder, is that relating to culture, as you said?
Religion in Utah, right? Because in Utah, you have a particular religious setting. Maybe that would be part of it.
And it could be even within Texas, you can see there is going to be that the state is not the right unit of analysis, but because even within a state, you're going to find very interesting variation that could also be driven by culture. It could also be driven by, as you said, policy. It could be a political party or views. It could be also driven by firm composition. Are you in sectors where there are a lower supply of women. So that may be the story of Seattle, which is an IT city. So many things that can inform the debate, and that's the goal. It could also, we also like these maps to help.
Sorry, Mercedes, I don't want to interrupt you, but I'm thinking, or definitely we can do that at state level, but like Austin, Texas, right?
Yes.
It's not just an island of happiness for female inventors, but if you look at this is the area with the fewer conservative voters in Texas. So that's why I was noticing these, the pink and blue in these counties. Of course, they don't overlap completely, but they look like, anyway, for instance, I don't know why Omaha, Nebraska is actually pink. That surprises me, but you never know.
And that's what we want to motivate, that people can use also this data to then think about why, and so that we can influence, so that we can then think about the policy interventions, the managerial interventions. To me, it's also sometimes very interesting, these very small dots of pink, they have very few patents, but they're very, very pink. Can a small set of firms have a big impact? That can be another question versus the big firms. The Seattle effect can be an Amazon effect, right? These big firms that concentrate a lot of the patenting. So, and that's part of the goal, to motivate this kind of analysis to induce change. Now, your other question, do females prefer other types of commercialization of invention, which is not patenting? And I want to be, we often get this comment, and and let me first say, we chose a contest, in the context of the universities, where that's very unlikely. We're talking about women that are doing a PhD in the top 25 universities in STEM in the US. So very hard to get in. Any PhD student, if you ask them, do you want to publish during your PhD studies, they all raise their hand. Will you want to patent? Of course, patent is a good, an important indicator of the relevance of your research, in particular in terms of commercialization of, of your invention. And more, obviously, firms care about that, and more than 90% of all the patents are generated by firms. And these PhD students, most of them are going to work in firms. So if you think about the rewards to patenting, is similarly relevant for the male and the female. They both could benefit of patenting during their PhD studies. So I think in this context is less relevant, although something still something that we did is try to figure out, perhaps even within a field, maybe there is variation between the female top inventors and the male top inventors in the type of patents that they're focusing and things like that, but we couldn't find differences. Now, the other thing that is not just about women prefer not to patent, is that actually when you reduce the barriers, you see them patenting more. For example, when you engage them as female PhD students in your lab, as we saw, many more of them are going to become new inventors. So once you start reducing some of the barriers, we see that they do increase patenting. That means that they do want to patent, but there are some challenges. Now, that doesn't mean that we don't have to look at other innovation outcomes, whether it's entrepreneurship, trademark, design patents. So far this analysis was for utility patents. Women do a little better in design patents, for example, per your comment. Looking at trademark, I think that's super interesting. Can we see how those numbers look in trademarks? But still, once again, in this context, we wanted to go away from that comment, which is an important comment. Women prefer not to patent. Well, you're going to MIT, to work with a top inventor, I think you want to do as well as possible in terms of your research outcomes. Also, when you think about the empirical design, because we're going to be comparing female top inventors with male top inventors, whether or not they're engaging new inventors, the difference cannot be just driven by that, right? Because given the kind of experiment that we're empirical design that we're setting. But it's an important question.
Very clear answer, very clear. Thank you very much, Mercedes.
Okay, now I would have two questions more, but I hope they don't mind if I abuse my role as chair to insert a small question. Can you hear me, Mercedes?
Yes.
Yeah, insert a small question related to this issue of propensity of patenting in this top step university. I was really shocked by the impressive role that PhD students have in this university patents. Okay, their role is really impressive, and you're motivated by saying that being in a top university, in a STEM university, is of course an incentive for PhD students to patent. The question is, do you think that this story is country specific? Would you think that you will have the same shares, the same kind of incentive in other contexts than the US, where the culture of technology transfer is definitely different from there?
Great question. So we are starting to implement this analysis in Denmark with some colleagues here. And I think we need to implement this type of analysis in other countries because perhaps it's not the case, but when you think about if you are running a lab, whether it's in the US or in Italy, and you are creating new knowledge, your PhD students are the best source of new knowledge. And you hope that that new knowledge is the type of knowledge that is going to be relevant for patenting. And so I will still think that they are an important pool of inventors to be at university patents. Now, I don't know whether the numbers are so high like in the US or in particular MIT, where the number is really high. But if you think about it, any of us writing new papers, potentially with your PhD students, you're creating this fresh knowledge, the new novelty of working with a PhD student, and you're hoping that will result in a good publication, and in this case of STEM education in patenting as well. But it's a question that needs to be tested in other contexts, and I think that will be fantastic to do next.
Right. So I really apologize with those who actually booked their question before me. So I leave the Masoud Ghazi, who is a postdoc of us, who raised his hand to ask a question. Masoud, are you still there? Sorry for taking my role.
No worries, Sandra. You raised a great question. So thank you very much, Mercedes, for a great presentation. I have a couple of questions, actually two. The first question that I would like to raise is regarding the social responsibility, because as soon as the PhD students finishes defending their PhDs, they are usually at the age that they get married or they have children. So that kind of factors is really missing in your observation. So that might have an impact on their, patenting or their later career, which is missing in your observation. And second question is related to the share of female patent from the universities. Have you checked that by the total number of PhDs, whether that makes a difference between male and female? Because if the share of male is higher and compared with the female, and then the number of patentings by both genders might not be that different. That's just my observation.
Masoud, I start with your first question, and then I will ask you to clarify the second question. So the first question about the age of these students, PhD students that become new inventor, meaning that they file their first patent during their PhD studies. So the good thing is that in this setting, they are young, right? They are PhD students. We're still not looking at postdocs. And so age, in the sense of being at risk of having children, is less so. We look at the data, and on average, at least at MIT, when they filed their first patent, the age was around 26 and 27, which is still is not the average age. The average rate at risk of having children for someone that have graduate studies is higher than that. So in this particular context, they are at a lower risk of having children, which could be a consideration of why engaging less in patenting. But also remember that they have chosen, and they're doing a PhD in a top university. So still, even if they were at risk of having children, the reality is that they have chosen to do this very high-level STEM education. Now, in terms of, so maybe also meaning that they are also more willing, given that choice, that they decided to do a PhD at MIT, they may be also more willing to postpone family to, or delay family up to when they are a little bit older. Now, but first of all, the average age 27 is lower than they are young. The other one is that if you think about the empirical setting of comparing the female top inventors versus the male top inventors, how they're engaging these female PhD students, for those two groups, the age of the female PhD student is the same. There is no reason why we should think that the female PhD students are going to be older when they work with the male top inventors and younger when they work with the female top inventors, and that could explain the difference. We expect them to have the same age for both groups. So it's not as big of a concern in our context.
Sorry, Mercedes, may I interrupt you here? Because,
yes.
As Alessandra mentioned regarding the culture, because the PhD students comes from different ethnical groups, right? And that might have an impact on their later career, like patenting. So, however, if you have mentioned that they are very young, let's say at the average of 26, 7 years, but if we take into account the culture aspect, then it might have an impact on their career. For example, if they come from India, or take into account because Indian students are mostly going to the US, so that might have an impact. Don't you think that?
And perhaps also is a bit out of context of the current analysis, in the sense that we're not looking at the productivity of these female new inventors during their careers. It may well be that, although we think it's very important to get this very first patent early on, that how that is going to affect your future career as an inventor is also going to be related to other factors like culture, as you said. But what is important here is that our pool, independent on the culture, already have decided to pursue a PhD in STEM in a top institution. But it's a great comment. Now, your second question, I will ask you to elaborate a little bit more on that.
Yes, I was wondering whether the number you've presented some figures on the share of patents from the females, right? Across universities, top 25 universities, right? Am I right?
The share of patents.
Share of female patents at top 25 universities, right? You've shown a graph.
The share of female PhD students, and then there was the share of female new inventors, the share of female patents. I'm not sure.
PhD students, I think it was related to PhD students. I think, is it? Yeah. So I was wondering whether that was based on the number of PhDs in each university, as and then they issued a patent. And then if you look at that share, that might not be that different between male and female. So that was my question, right? Did you get it?
So are you referring to figure 1? I'm trying to, sorry.
Yeah, if there was a figure on the universities.
You mean this figure looking at the supply?
Yeah, even if we look at this, for example, we see that, okay, this is the female, right? 25 top 25 universities. Female is 10 PhD fellows, right? And then,
yes.
Then we have the female new inventors, and then at the same time we have male. So is it based on the actual number of PhDs in each university?
Yes, yes. So this flow here, it's actually, we're looking at these 25 universities. We are looking at the PhDs granted in STEM by gender during, it's a flow during this time period. For example, for 2015, we're looking at, when we compare female new inventors in 2015, we're going to look at PhD students granted from 2010 to 2015. Yes.
Thank you.
All right. So now there will be Andrea Scani actually ask on the chat. I don't know whether Andrea, you want to pose a question yourself or report a question from YouTube. I don't know.
It was a question from myself actually. Yeah.
Go ahead.
Yeah, thanks. Thanks for the presentation, super interesting. I had a question that is partially data related and might also offer some more conceptual insight as well. So you're using data on inventors that have a PhD. I guess that's a very large share of inventors. But I also guess that in some specific fields, there might be a higher incidence of inventors without a PhD. So I was wondering whether you know any information about this. For instance, there might be lab technicians, engineers that participate in patenting. And this can be unbalanced towards one gender or the other. So for instance, if there are labor market frictions that prevent females to enter a PhD, but they're interested in the job, they might just, I don't know, stop there and become a lab collaborator.
Perfect.
Or vice versa. I don't know.
Andrea, it's a great comment, and we have both, right? So in some of the analysis, we're looking at the percentage of all female new inventors out of all the new inventors, and new inventors can be PhD students. We saw it's a high percentage. They can be postdoc. They can be master students. Actually, at MIT, around 7% of those new inventors are going to be, as you said, they don't need necessarily to complete a PhD program. A master could be enough. And that in the first indicator, this percentage of female new inventors of 22% across the 25 universities in 2015, that include all of them. The analysis we did towards the end to try to understand better the mechanisms, there we did look at the PhD students that become inventors, because in that particular analysis, then we can compare the actual population at risk of becoming an inventor, which are the graduate students of the top inventor, to those that actually do become inventors. But you're totally right. It is not, you don't necessarily have to have a PhD or a postdoc. And it's something also that we're discussing with firms, because in order for firms to figure out what is their supply of STEM skills by gender, we need to understand what kind of skills you need. Is it a PhD? Is it a master in STEM? Is it something else? So extremely relevant question. You're right. It doesn't need to be just PhD skills.
Thank you.
All right. Thank you, Andrea. I forgot to mention that Andrea is also part of our staff. He's assistant professor at us. Then I have two questions from Ugo Rossi, who's assistant professor at the GSSI. Ugo, are you there?
Yes, here I am. Thanks, Mercedes, for your very interesting talk. I have a question which touches partially upon something already Alessandra asked about the commercialization, but my question is there a different way of doing innovation by the women? And what is, are they more inclined to do social innovation compared to men from your point of view, based on your empirical observation? Social innovation, I mean something that is less profit driven and is more experimental in terms of dealing with issues of ecology, of equality, social equality, of inclusion, and so forth, rather than extracting a profit from the innovation activity. Thank you. Sorry.
You know, I think it's an important area for research. It's thinking again about the different manifestations of innovation. We look at patenting, but it could be trademark, it could be here you're introducing social innovation. What we see, for example, prior work have seen in terms of the patenting, there's still women patent, but they may choose to patent in innovations related to problems that are more relevant to women. So for example, when you think about patents related to drugs, you know, medtech, chemical, they maybe have a higher propensity to focus on finding solutions to problems that are more relevant for women. And that's important too, because if the majority of top inventors are male, we may be emphasizing research questions and solutions that are good for male population, but not necessarily for the female population. So that's an aspect where even within patenting, women may have different preferences on the problems that they're trying to solve. You know how, but I think more broadly is that we need to, as you said, try to better understand how to measure innovation, including, for example, innovation in services. Maybe part of social innovation is that you're going to offer new services that maybe those are less likely to patent. So maybe then that goes back to the idea of looking at trademarks or maybe design patents or maybe other instruments that could tell us whether, to what extent, women are represented in those types of innovations. I think we have a lot of work to do, because also, if you think the first slide, it's a global problem. You will have thought that Denmark, that has a lot of family-friendly initiatives, somehow you know, inventor gender gap will be lower, but still is very high, right? Only 13% of the inventors are women. So I think we need to ask the type of questions that you're asking, and there is a huge opportunity for research and for collaboration across fields as well to try to answer these questions.
Thank you.
Okay, now it's the turn of Alessandro Palma, who is a postdoc at the GSSI. Alessandro, are you still there?
Yes, I'm here.
Okay, go ahead.
So hello, Mercedes. It's Alessandro Palma from the GSSI. So first of all, thank you very much for your talk on this super interesting topic. I have both comments and questions for you. So I think the roles of selection and the switching stage between academia and the labor market is key to determine the current gender gap pattern. And I think about two kinds of selection processes, external selection and self-selection. So, for instance, university is the first place where external selection works. And even though there is a lower gender imbalance in the academic market, much less women are involved in the labor market. So this means that there exist specific barriers to access the labor market of inventors. once you complete a PhD or a master. Another issue is on the role of self-selection. For instance, do women self-select into a specific industry, for instance, drug and pharmaceutical, as you already showed, or the specific industry itself is able to attract more women? And a third mechanism of related to self-selection is regards the top inventors. I think a woman with very high motivation to invent is more resilient to the large barrier existing both in the academic and in the labor markets. So it's not surprising to me, relatively speaking, to see more women within top inventors. So in light of this, and I come to my question, in your view, what are the main barriers faced by women in switching between university and the labor market, and how these gaps can be filled? For instance, through big salary premiums, but in this case you might discriminate against men, or by imposing stricter female quotas, or by exploiting the key attraction role of top women inventors. So what's your opinion about this issue? Thank you.
It's a huge comment. I guess I first will start by saying that the paper that I have presented focus on engaging women in patenting, but I think we also need to learn what happened afterwards. You know, and then you can compare, you know, those women with STEM PhDs, the ones that got the first patent during the university versus the one that did not. Do they have different opportunities in the industry sector, and do they perform differently or not? Now, understanding those mechanisms is very complex, and I think part of a challenge that we have is that we need to be co-creating more with some of these big firms that are, you know, that patent a lot, because we may be making assumptions, but then when we talk to them, we realize that actually we're not modeling the problem properly. So for example, we, the team, we've been engaging with some of those big firms with their top inventors, who now in firms, very often the top inventors later on can become managers themselves, precisely to understand that, you know, what happened, what is the criteria for hiring, and, you know, one thing that the reason we thought it's perhaps one of the reasons why it's so important to get this first patent early on during your PhD studies is that once you enter in a firm, at least, you know, with this particular firm that we are co-creating with, they explain that sometimes these female top inventors within the firm, they started patenting with the firm much later than the male top inventors. So there was a delay for them to start patenting within those organizations. Then you need to try to understand why. But you see, the discussion can keep going because there are so many potential organizational drivers that can be driving, that can influence this, you know, gender gap in innovation, both in universities and at the firm level. Now, based on our results, you're saying, okay, if you think about policy initiatives, I do think we need to be serious about having more female top inventors within organizations, because they definitely, we saw in the data, and by the way, we see the same pattern within firms. The female top inventors within firm engage more women in patenting, but they still are a very small percentage of all the top inventors. We need more female top inventors. They're going to be attracting female PhD students, are going to be mentoring them, they're going to be transforming them into inventors. So I think we need to be very serious about reducing those barriers. And as I mentioned, some of them, it's a matter of grants and resources. So then let's make sure we're allocating grants to female faculty so that they can start labs and that they can become top inventors. It could be, as we mentioned earlier, access to industry. So then let's be more clear about how can we engage more women in corporate boards. But I do think if we want to really make a difference, we have to have some strong interventions and also be very clear based on proper data and analysis that there are these barriers and we need to reduce some of those barriers. I don't know if I have sort of answer. It was a big question. If I have answered your question or not. Now, perhaps the other one is that male top inventors are very important. We also saw that they are more inclusive than non-top inventors. But we also need to recognize, at least based on the analysis, that they need to be also engaging more women scientists in their teams to give them also the opportunity and training to become inventors. Alessandro, so what do you think?
Thank you, Mercedes. No, your answers are very clear. I was wondering what could be the most effective incentive just to provide more funds for top women inventors, or just spread the funds on all potential position to women inventors. So there's a trade-off. So I was interested on this issue just from the policymaker perspective. So I think you were very clear in answering.
And I think we need more research to actually try to understand what will be the kind of interventions that can have a bigger impact. You know, something that we can do in the context of this project is actually estimate the missing female new inventors. Those female new inventors are missing because the ratio of PhD into inventorship is lower for the women PhD students. So you can come up with actual numbers and then put an economic value into that. And then think about then what is the kind of intervention that those numbers could motivate. The missing female new inventors is a very large number with a very high economic value. And social value, remember that this is also a social problem. The fact that and that also has been recognized by the UN nation, that it's a huge, not only economic problem, because an inefficient use of human capital, but also it's a big social problem because if, for example, if they don't become inventor, they may also have lower wages, and that also have other implications for their careers and for their families. So we need more research.
Okay. Thank you.
Right. Thank you to both. I must admit, I just realized that I downgraded the status of Alessandro from assistant professor to postdoc. Sorry for that, Alessandro. Alessandro is actually assistant professor. There was another question booked, but I don't see it anymore. So, any other question? We had a nice discussion, I think, at the end. No, there's Fabiano, our assistant professor, GSSI. Fabiano, you want to pose the last question? Then I think that we should actually close because we ran out of time. Okay, Fabiano, go ahead.
Well, thanks, Sandro. Thank you very much, Mercedes, for your interesting and timely presentation. I have just an observation which is related to that of Alessandra, which stressed the role played by culture. I was reading an article which stressed the fact that the highest share of women among investors is in Russia. And we know that the Soviet Revolution supported the entry of women workforce in the labor markets, granting, for instance, say minimum wage and rights. So I think that you told us that you are expanding your range of interest toward Denmark. And yes, I think that maybe considering different countries could be in order to try to assess the role of different culture and path dependency related to the different cultures all over the world.
Great, and I totally agree that this is an important area for future work. And then also, when you remember the map, even the places that are doing super pink, that is still very far off from parity, which means that even a very, inclusive city is still very far off from that parity. So we need intervention from many different organizational angles.
Thank you very much.
All right. Okay. I think that if there are no more questions, I'm afraid those reasons have already been addressed. So I don't think that they still have questions to pose, right? Alessandro, Ugo, and Fabiano, these are holdouts, are they? So if there are no other questions, I would close session of today by thanking again very much Mercedes for this really excellent presentation. We heard a lot of interesting stuff, and I think that we received from her also inputs for possibly addressing related research question to the ones that she addressed. So Mercedes, thank you very much. And
thank you, Mercedes. Thank you.
Thank you all for the opportunity and the questions. And I think there is a huge research opportunity in this space for many of us to understand the organizational, but also the cultural and the locational drivers of the inventor gender gap. So thank you for the opportunity to present the work.
Right. Thank you to you. And let us see, hopefully, physically somewhere. Okay,
that would be nice. Next time, face to face. Exactly.
Yeah, hopefully, yeah. Okay,
Stay healthy and well, everyone. Thank you.
You too. Okay, bye. Thanks a lot. Bye.